Good afternoon, everyone. You're very welcome to Construct Innovate webinar series on innovation and entrepreneurship. My name is Magda Hajdukiewicz. I'm a director of Construct Innovate, Ireland's National Research Centre for Construction Technology and Innovation. And today we are discussing innovation case studies, and we have three fantastic speakers with us today. The first one is Dr. Sean Mulligan, CEO at VorTech Water Solutions. And Sean is going to talk about innovation in the water industry. Our second speaker, Dr. Vedant Modi, project engineer at ÉireComposites Teo, and Vedant will be discussing ÉireComposites and its recent innovations. And our final presentation will be from Philip Cheasty, a national contact point for Horizon Europe Cluster 5 on climate, energy, and mobility at Enterprise Ireland. And Philip will go through Horizon Europe work programs and the benefits to construction and built environment sector. So very exciting presentations. We'll start with those three presentations, and then we'll follow up with the Q&A session. So if you have any questions regarding the presentations, please type them in the Q&A box at the bottom of your screen, and we'll come back to them at the end of the presentations. So I hope you enjoy the presentations, and I'm going to ask Sean first to share his slides. Thanks, Sean.
Thank you, Magda, for the intro. I'll just share my screen. Can you confirm that's up there?
Yeah, perfect. Thanks.
Excellent. Well, hello, everyone. Good afternoon. It's a pleasure to be here as part of the Construct Innovate series on innovation and entrepreneurship. It's a very important topic, I believe, particularly if you're coming from the area of civil engineering, but all the areas of engineering. So what I'm going to present really is, I guess, my story coming from originally civil engineering academia all the way into starting up a new technology company in the water engineering space, and a little bit about that journey, along with some tips in terms of how our journey has gone to date. But just to kick off with a bit of background on myself, I am originally a civil engineer. I studied at the IT Sligo undergraduate in civil engineering, which is now ATU. A big focus of that undergraduate civil engineering degree was actually on water engineering, hydroelectric power, wastewater treatment, and so on, with a lot of practical activity. So at a very young age, I was very focused and very passionate about this area of engineering. Largely, I believe, due to what I seen at the time was a lot of opportunity to do a lot of new innovation. There was a lot of questions that I seen that were unanswered, particularly when it comes to the hydraulics of open channel flows around wastewater treatment and so on, which I'll come back to as we progress the presentation. When I advanced throughout my undergraduate, I realized that I could progress into what was called research at the time. I progressed into doing a master's by research in the area of hydroelectric power engineering, looking at small-scale hydropower generation from rural communities in Ireland. And that then quickly progressed actually into an unusual career direction of looking at vortex flows and the deep scientific nature of vortex flows for hydropower generation, but also for other applications such as energy dissipation and sewer systems and so on. Really then my career route went really into the scientific nature of these types of flow phenomena and answered the questions that were need to be answered in terms of academia. But in coming out of that, I really started looking at application of these types of flow phenomena in modern day civil engineering applications. A lot of my work really was focused on hydraulic structures, wastewater treatment, hydropower. But really, well, at the end of my PhD, I thought there was a significant application of vortex flows in the area of wastewater treatment aeration, along with hydropower. So I then teamed up with Professor Owen Clifford at the University of Galway, and looked at seeking Enterprise Ireland commercialisation funding to progress this research further at the University of Galway. So that eventually led to spin out of VorTech Water Solutions, which I'll describe in more detail. But in summary, I've been working on a number of academic projects, but also large-scale infrastructure projects across the industry. both in collaboration with the University of Galway and also with other industry partners. In terms of today's presentation, really it's about innovation and entrepreneurship. And I'm a firm believer that innovation is really finding solutions to some of the world's greatest problems. And when it comes to the world of civil engineering and wastewater treatment, we have significant problems facing this industry in future years. So we're talking, at the moment, some 80% of our wastewater is still discharged to the environment globally. And as a result, that contributes to some 830,000 deaths per year across the world. The emissions associated with wastewater treatment are significant. In fact, the emissions in the wastewater industry is equivalent to that of the entire aviation industry. So it's very significant. When you take the electricity required for wastewater treatment alone, some reports have found that it could be as much as 3 to 5% of global electricity usage. So it's very significant. But on top of this, obviously, our populations are growing significantly. More volumes of wastewater are being produced. We have more stringent discharge regulation to achieve. And we have to do all this with aging infrastructure as well. So across the world, a lot of our infrastructure is aging at an incredible rate. So when it comes to the wastewater industry, innovation means, my opinion, is providing solutions to some of these significant global problems. So going from there, this is where VorTech comes in. VorTech is a spin-off company that I founded from the National University of Ireland Galway, or the University of Galway, Ireland. As I mentioned, following four years of commercialization funding, we developed novel technology, sustainable technology, to solve some of the greatest problems around wastewater treatment, which I'll take you through. And these solutions are based primarily on vortex flows. But what we've done is we've brought together a very unique skill set, or an interdisciplinary team from areas such as energy, process engineering, biochemistry, and fluid dynamics. And we're building up these technologies with the fundamentals requirements of wastewater treatment in mind, meaning the requirements of operators, the requirements of decision makers at a sea level, and also in terms of achieving sustainability metrics. So as a result, we've developed novel class of aeration technology based on vortex flows. And we've currently been deploying these technologies across Ireland and the UK over the past several years since our spin out in 2020. But more recently, we've achieved projects, and we're delivering projects more globally in countries like Australia and the US as well. In parallel, given our background in fluid dynamics, we also offer high-value services to the industry, which are based on fluid dynamics, so what we call computational fluid dynamics. So we're able to simulate very complex flow processes in very complex civil engineering hydraulics environments, such as around pump intakes, around wastewater treatment plants, and so on. So just a little bit about our technology. Well, if you were to look at wastewater treatment over the last 100 years, you basically have at the heart of the wastewater treatment process, you have what's called the activated sludge process. I'm not going to go into it in too much detail, but what it does require is the cultivation of bacteria, which digests wastewater in the presence of oxygen, essentially. So what the process requires then is driving air and therefore oxygen into the bacteria so they can respire as they treat the pollutants. We have carried out this aeration process in these bioreactors for the last 100 years or more, using what are called mechanical surface aerators, which is shown on the left. And these technologies worked well, but the problem was they're energy intensive. They also generate a lot of sprays, a lot of noise, and in many cases can be quite costly or complex to maintain. Since the 1990s, then, what has started to become the default choice in the wastewater industry is what's called diffuse aeration. So rather than agitating the water at the free surface, we instead draw air into the bottom of a reactor to meet the water in the bottom of the reactor through what are called diffusers, or fine bubble diffusers. What this requires instead now is a very complex retrofit where you need to put all this equipment on the bottom of a reactor, but also external components, a lot of civil works and mechanical works for the installation. But more importantly is, because all of this is submerged under sometimes 4 to 5 to 6 meters deep wastewater conditions, failure of a diffuser could result in significant maintenance requirements. often requiring standby tanks. And in many cases, we've understood that when there's no standby tank, end users have required scuba divers to actually drive down to the bottom of reactors and fix the problem. So this is significant. It can really drive up the costs of a treatment plant when you consider its life cycle over 40 years, for example. So what we've developed, and that's just a summary of some of these challenges, what we've developed is a brand new class of technology called vortex powered aeration. And what we do that's different is we're going back to basics, relocating everything back at the surface of the tank. But rather than bringing air to water, we're bringing water to air in a cyclone. And we're doing that very efficiently using the pump technology. But really the benefits are down to easier retrofit, easier maintenance because there's no submerged components below the waterline. Everything's accessible above the waterline, which is a lot safer for ongoing maintenance and no need for tank draining. But also ongoing energy efficiency. We can maintain very good controllability of the technology under process conditions to achieve high energy efficiency as well. Over the last 3 to 4 years since our spin out from the university, at which point we spun out, we developed the technology to what was called Technology Readiness Level 9, following the Enterprise Ireland Commercialisation Fund. But since then, we've been getting the technology into customer reference sites, and we've done a lot of very significant reference sites across Ireland and the UK. For example, with Irish Water, we've worked with abattoirs like ABP Food Group, we've worked with global dairy companies, and we've worked with global beverage companies as well. So on the image here, you can see some examples of our full-scale reference sites. And it's a testament really to coming out of the university with new technology, building relationships, which we call early adopters. They're the innovative pioneers in the industry that realize the value of innovative technologies in solving problems. And I'm talking about companies like Wardenburg Construction, who we've done a lot of work with to date, who really see the value of bringing innovation into the wastewater industry to drive value and solve problems. We've done a lot of work with them, but also in companies such as ABP Food Group, where they realize that to achieve sustainability targets, they need to embrace innovation as well. So it just gives a little example. Just 2 examples on some case studies with our technology and also our services. I mentioned the abattoir project a moment ago. So this is an example of an abattoir project in the UK. There's a lot of detail here, but in summary, they had an old facility that was doing very basic treatment and resulted in a lot of cost. The cost was due to trade effluent charges, but also chemical usage to do very crude variations of treatment. The problem is that ongoing treatment was going to increase due to a 30% increase in production at that facility. So they had to do a complete plant upgrade. In that case, the abattoir group, ABP Food Group, were considering sustainable alternatives to the upgrade because they needed to consider a technology that was very low in maintenance, produced a very low noise, and was able to be energy efficient due to the need for additional energy requirements at the site. So as a result of various desktop case studies, ABP Food Group went with VorTech Water Solutions for the upgrade, and you can see the old site on the top right and the new site on the bottom right. And just to give an understanding and a quick video on what that project looked like, this is where we fabricated the unit. And in this project, we partnered with Wardenburg Construction, who, as I said previously, are world-class provider of construction services, particularly in civil engineering, but also in water and wastewater treatment infrastructure. So they partnered with us in this project to deliver the project management and installation of the project. And you can see the Wardenburg Construction operators assembling the VorTech equipment that we supplied in the background. And this is the aeration tank before upgrade. And following upgrade then, we were able to install within 10 days, get the system up and running and start treatment at the facility. In summary, the facility has resulted in significant total life cycle savings. And in this industry in wastewater, sustainability and total life cycle cost savings really go hand in hand. And that it comes in the form of maintenance savings, energy savings, replacement savings, and also carbon emission savings. So what we were able to do at the end of that project upgrade is go back and work with the client to collect the data to verify the value that our solution was bringing. And you can see some of the impact here in terms of 30% saving electricity, carbon emission savings, and also savings in terms of maintenance, and over the total life cycle of the project in 20 years, a 2 million saving in operational and capital cost savings there. I mentioned previously fluid dynamics, so a very quick screenshot of some of the work we do. In hydraulic infrastructure, obviously in the open channel side of water engineering, we have a lot of complex phenomena that occur. And that's complex because you have a mixture of particles, oils, rag and grit and so on. But we also have air-water flows. All this is very, very complex to solve using conventional analytical methods, and therefore calls for more complex approaches to understanding fluid dynamic principles. You can study it in a laboratory using a physical model, but we've also now in recent years started to leverage what are called computational fluid dynamics. So what that allows us to do is basically, in a three-dimensional environment, model what that fluid flow process would look like. This is a very quick example of a project which is called a vortex drop structure. Given that we have a lot of expertise around vortex flows, we've been simulating a lot of vortex drop structures, which are essentially energy dissipation systems for large-scale infrastructure across the world. And because the flow processes are quite complex, it does often require for a mixture of physical modeling, but also supported with computational fluid dynamics. So on the left is an image of the structure that's deep below the ground level. And essentially, the original design was undersized and was overflowing as a result of a poor understanding of what the actual fluid dynamics principles would look like. So as a result of computational fluid dynamics, you can see we're able to model up the dynamic flow processes and then resize the overall structure. So it was able to maintain capacity to meet with the design requirements of the facility. After it was built, then you can see the client actually got a video of the system working, and we were able to compare back a full-scale prototype of the system working to the actual numerical simulation. There's obviously a lot of detail in the background here, but it just gives you an understanding of what we can leverage from an academic environment in terms of fluid dynamic science to provide impact in this wastewater industry. Just then to wrap up on this slide, a little bit of innovation outlook on particularly regards to wastewater and water, but generally applies to all areas of innovation. I believe in the wastewater industry, we've only scratched the surface in terms of what we can do. There's a significant opportunity for innovation across the overall industry in terms of applying computational fluid dynamics, digitalization, and also leveraging more complex instrumentation to understand complex flow processes. And we're actively collaborating with the University of Galway through a project called Nexus, where we're doing some of this kind of more strategic research in order to bring, a new understanding and new standards into the industry. But in general, innovation, as I said previously, is all about finding solutions to problems, whether it be in mechanical engineering, biomedical engineering, and so on. But when you really develop a deep sense of passion and purpose to drive in that solution, and it may not be in a startup company or a license, it may be in the form of a paper. It really does come down to relentless focus on execution to really bring that to life. But really, when you're innovating, there has to be a focus on value creation. Working with customers and understanding what their real pain points are, and then focusing on solving them problems. And really, rather than thinking you have the solution to a big problem at lab scale, you really need to get out and speak to customers. It's also important to note that don't be afraid to ask. Along the way, I've learned it's very important to go and ask the customers, would you pay for the solution? Because of course, every business has to make money as well as value creation. Again, as I said, recognize opportunities, and along the way, it's very important to recognize as well that as you develop your solution and bring it to market, or you develop that paper, a strong team, relationships and partnerships are going to be critical to success. So it's very, very important to realize that at an early stage. And I guess the last point for me is don't forget to enjoy the journey as well, which is very important, whether it be in academia or in industry. So thanks for your time, and I look forward to any questions you might have after the seminar.
Thanks very much, Sean. That's great and fantastic to see the journey that you took from the researcher to spinning out a company and then bringing a real product to market that is making the difference. Thank you. I'm going to ask Vedant now to share his slides and proceed to the presentation.
Yeah, can you see my screen properly?
We see the screen, but not in the presentation mode yet. Oh yeah, perfect. Thank you.
Okay, thanks, Magda. Thanks, Sean. That was very interesting what you said there now. So just before I start, I'll introduce myself. So my name is Vedant Modi. I've been at ÉireComposites for 2 years now, and I'm a project engineer here. About my background, so I actually studied in the University of Limerick, where my PhD was in composite materials. So what is composite materials? For those who don't know, it's basically a mixture of two different materials with different properties. So that would be the basic outline. And what does ÉireComposites do? And our recent innovations is what I'll be talking about next. So ÉireComposites, it was actually, just like Sean's company, was a spin out from University of Galway in 1998. We're about 60 employees and we're on the west coast of Ireland. We're overlooking the Atlantic. We are commercial manufacturers for commercial aircraft, like the Bombardier aircraft and some Airbus aircraft. And anything that goes into space or even aircraft requires testing. So we have a composite testing lab as well. And most of our innovations is done through R&D. So in terms of equipment, it is quite essential when you're manufacturing big parts, you require equipment. So our two autoclaves, which you can see on the top, are our major equipments where most of our parts for the aircraft are made. We also have some scanning equipments for testing of the parts, and we have different equipments for R&D purposes followed by them. So our commercial industry is for aircraft. So we have experience in manufacturing thermoset and thermoplastic composites. For those who don't know what thermosets and thermoplastic composites are more older generation materials which are non-recyclable, and the future is into thermoplastic composites, which is more recyclable and it can be repurposed and remolded as well. So the parts we make are being flying in commercial aircraft since 2008. Like I said, they're made for Bombardier global aircraft and some for the Airbus A220 and the MC-21. So what we make for them are mainly skins, spars, panels, ribs. So they're marked here, which go onto the rudders or the control systems of the aircraft. We make some spar angles for the A220 wing, which you can see in the figures where they're outlined, and also a lot of cabin interior components for the A220 and some parts for the jet engines. We've also done development and production for military aircraft like the A400M. If I move into R&D, our recent innovations have been for a company in Dublin called Mana. So their goal is to enable drone delivery for last mile, so delivering of food, medicines, etc. So we currently make their airframes, and this was done under a DTIF, Disruptive Technology Innovation Fund project called My Drone, where we designed and developed in collaboration with Mana and University of Galway, a drone airframe. We've also recently developed drones for ATEXN. It's a company based in Shannon who deliver similar components, but they have a long range hybrid system using gas as well. In terms of space R&D projects, we are currently the first company in Ireland which are making stray light baffles. As you can see, the stray light baffles are the 3 cylinders on the left figure, and they will be deployed in 2025 from Papua New Guinea, and they'll be the first parts ever made in Ireland to go to space. We also collaborate making ATG lattice cylinders. So this is an R&D form of a project where we made space cylinders, which can be deployed or changed in the future using thermoset materials rather than metals. We've recently also started a freeform optics project, which will use mirror satellites and will be for high precision for communication networks. And we hope to deploy them by the end of 2025. There are lots of R&D work we do in terms of renewable energy as well. So we have commercial R&D projects which range from 3 kilowatt turbine blades to 15 kilowatts for a UK-based manufacturing company where we manufacture the blades. But in terms of R&D projects, we're recently deploying a tidal turbine blade in the north of Ireland, which we had done through an Horizon 2020 funded project called Crimson. The blade manufactured was in collaboration with ORPC, where we manufactured a composite thermoset tidal blade. Recently, we started to manufacture a Susta blade as well. It's a sustainable wind turbine blade, which we will manufacture using recyclable materials. Like I said, so it'll be more thermoplastic materials. And we hope to deploy them as well by the end of the project. There's loads of offshore wind energy projects we do as well. They're all funded by the SAAI. So STEP for Wind is a project which is collaboration with 10 different universities, and we'll have about 10 different PhDs graduating through this project. Merwind is also a project where we'll be manufacturing tidal blades using thermoplastic composites. And Deep Wind Demo is led by MMI, a company based in Ireland, where we're also manufacturing tidal turbine blades through SAAI funding. This aim is to design and test a novel deep sea wind energy demonstrator, and it will be deployed in Clifton in the August of this year. We've also done some commercial projects in terms of R&D work for Wavefoil. So Wavefoil is a Norwegian company which provides retractable bowfoils. As you can see, the ship can generate power, and it also makes it more cost efficient, reduces carbon emissions, and helps the boats to move faster. They were up to 6 meters in length, and they have been deployed in the Norwegian ship recently. To move away from Wavefoil, we also made Fast Ship. Fast Ship was step 2 of the Wavefoil, where we are manufacturing the Wavefoils using sustainable materials, which can be further deployed in the future, reducing cost and improving the fuel efficiency for boats and ships. Not recently, but about 8 years back, we manufactured sports goods, which are saddles. They're made from a thermoplastic material, which reduces waste by 60% and provides more comfort for horses and riders and allows them to move more freely. This had also won an innovation award for sports and leisure in JEC, which is one of the most important conferences for composite manufacturing materials. Like I said initially, for anything that goes into space, we require testing. So anything that is manufactured or developed is going through a test lab at ÉireComposites, where we perform all material characterizations before we could deploy them. But most importantly, what are lessons learned when we perform these manufacturing ideas or new technologies? Material selection. It is quite critical to understand the different properties, the way the properties are generated at different temperatures, what the material properties are, and their strengths, and then identify the suitable material for its application. Manufacturing processes is quite critical as well. Composite materials can be manufactured using different techniques. Some can be manufactured in an oven. Some can be manufactured in a high pressurized oven called an autoclave. So these different properties are used, and then they are tested to find the most optimized properties for its applications. But when you're manufacturing something, cost should be taken into account as well, as a customer may not want to spend that much. So cost considerations are also taken into account for its commercial viability and its demand. Anything which is done in terms of manufacturing also has a lot of environmental impact. And like I said, thermosets are not recyclable, so they can not degradable either, so they can affect the environment. So a lot of consideration is also taken on the environmental impact of composite materials before manufacturing. All the R&D work we've done to date is with collaboration. So collaboration is quite critical, and it increases creativity and innovation. Patience and persistence is quite important when it comes to technology. Innovation takes time and perseverance. It is not always going to be right, but you can eventually get there if you keep trying. This comes with failure as well. As I said, there's been projects where we have had failures, but we've learned from them, explored and experimented, and officially succeeded. Anything that is manufactured can be improved as well. So embracing a culture of continuous improvement and innovation is essential for staying competitive and addressing emerging challenges. And thank you so much. If you have any questions, I'll be happy to answer them at the end.
Thanks very much, Vedant. No, it's fantastic. A great overview of ÉireComposites' work in the composite manufacturing field. So thanks for that. I'm going to ask Philip now to share his slides. Whenever you're ready, Philip. We see the presenter's view.
Okay.
Perfect.
Okay.
Thank you.
Cheers. A bit on for engineers, you probably got the first two presentations were probably the most interesting in terms of technology, seeing technology. So this particular presentation is about the funding mechanism. And I do know that both Sean and Vedant and ÉireComposites particularly have been quite active in the various European programs, Horizon 2020 and Horizon Europe. They have quite a lot of projects linked with those programs and funding coming from those programs. So some of the questions might be answered by those guys at the end of this. So I'm Philip Cheasty. I'm with Enterprise Ireland. I'm part of Ireland's Horizon Europe network. Enterprise Ireland managed the network for Horizon Europe, and along with other agencies, we cover all the different areas of Horizon Europe. So for within Enterprise Ireland, we would have national contact points. I'm a national contact point for energy in the Cluster 5 section of Horizon Europe. Within Enterprise Ireland, we'd also have ICT, national contact points, mobility, security, etc. But we do work with the other agencies like the EPA. The EPA would cover some of the environmental programs. SEAI are also involved in the energy side. And SFI also do research funding and also link that to Horizon Europe. So, I mean, this presentation it's just really an overview of Horizon Europe. The main point would be that there's plenty of contacts that you can get in touch with. If you're unsure of who to go to, just come to myself and I can point you to the appropriate people. So, Horizon Europe really, the funding for Horizon Europe is determined by the Commission based on the other strategies that the Commission have. So the Green Deal is the Commission's strategy to make Europe climate neutral by 2050. So the Green Deal is really an overarching strategy program for the Commission, and it filters down into all the areas of funding that the Commission target. So at the start of Horizon Europe, the strategic plan was set out to cover 2021 to 2024. It laid out the areas for funding, it laid out the areas of interest, it talked about the impacts and what they were hoping to achieve with the research and the innovation that they were expecting. And then at the end of 2023, there was a review of Horizon Europe, and the continuation is a new strategic plan for 2025 to 27. And that targets the three areas of the green transition, the digital transition, and a more resilient, competitive, inclusive Europe. Excuse me. So you can see there, like Europe now is a totally different world in 2024 to what it was in 2020. We have advanced climate problems. We have war and energy usage. COVID was kicked in terms of the health side. So Horizon Europe has sort of changed a bit of focus, and we're now looking at very much sort of a green transition and the digitalization of the various areas. So when you look through Horizon Europe, and if you look at any topic, you'll see the digitization involved, whether that be in health or in energy or in manufacturing. So the strategic plan sets out the goals for the next few years. So Horizon Europe is a 7-year program. It has 95 billion, so it's a huge program, and it's broken into 3 pillars. So pillar 1 really is the excellent science pillar. That has the European Research Council. So that looks for excellent researchers to do very risky research, early stage research, low TRL research. And then pillar 3 takes in the European Innovation Council, and that is targeting SMEs and providing support for SMEs to grow. Pillar 2 is the main body of Horizon Europe, you could say, in terms of the funding anyway. Pillar 2 covers the global challenges and the European industrial competitiveness. It has 6 clusters, so the areas are broken into clusters. So 6 clusters. So I cover cluster 5, which is climate, energy, and mobility. and specifically cover the energy part. Now we have NCPs, whether it is within Enterprise Ireland or the other agencies, to cover all the parts of each cluster. So there's plenty of people that we can talk to target the different areas. So it's a 7-year program. And one of the ways that the Commission actually interact with the various organizations, be it industry groups, member states, etc., are through partnerships. So linked to Horizon Europe, there's 49 partnerships currently, and they cut across all the clusters. So the 6 clusters, you can see there, cluster 1, 4, 5, and 6, they have a number of partnerships. So the partnerships are a way for the Commission to put funding into specific areas. So for example, if you look at cluster 5, there's a partnership there in the navy blue called Built for People. That's the partnership dealing with the construction industry. Under Horizon 2020, it was called Energy Efficient Buildings. And then under cluster 4, you can see the partnership around Process for Planet. That is a sort of a follow-on to the partnership under Horizon 2020 that was called Factories of the Future. So the 3 different types of partnerships. So the navy blue are the co-program partnerships. So what that actually means is those partnerships, and you can join those particular partnerships, you can become a member, you can get on working groups, and in the co-program partnerships, they develop up the topics that end up in the work programs under Horizon 2020. The co-funded partnerships are partnerships where the Commission puts funding into a pot, the member states put funding into a pot, and then they run their own calls. So you can see under cluster 5, there's a Clean Energy Transition Partnership down at the bottom. The Clean Energy Transition Partnership gets funding from SEAI and the department, DECC, and also now SFI have joined in. So they run their own calls. So as well as all the work programs and the calls linked to Horizon Europe, a lot of these partnerships will have their own funding mechanisms and their own calls, and their own brokerage events, etc. So something to target. Excuse me. And then the final type of partnerships are the institutionalized partnerships. So, for example, the Clean Hydrogen Partnership, that's a partnership funded by the Commission fully, where they run their own calls. So the co-funded has national funding, and under the co-funded, the national funding from SEAI goes to Irish partners. So that's a sort of something that you should target. Whereas the institutionalized partnerships, funding is open to anybody in Europe, and it's managed by the partnership itself. There's 49 partnerships. There is a discussion at the moment about creating 10 new partnerships. And under cluster 4, which is the digital industry and space cluster, there's 4 partnerships earmarked to start around 2025 around innovative materials, textiles and raw materials, and also some ICT, virtual worlds, etc. So there is a discussion about 10 new partnerships that could come online around 2025, 2026. So the partnerships are quite important to look at, and whatever space you're interested in, you should also look at, as well as looking at Horizon Europe, look at the partnerships linked to it. So how does the calls come out? So the Commission under Horizon Europe run work programs. So each cluster will have its own work program. So we're at the end of the 2023-2024 work program. Because of the 7-year cycle, we're going to have a single year work program for 2025. We will get a draft of that, the first draft of that work program later this month or maybe next month. We will go through a number of iterations before that 2025 work program is completed. And then that will be launched by the Commission towards the end of the year. And then the calls will open for probably with the first deadlines of March, April 2025. So we should know then what sort of topics will be available to target for 2025, like within the next few months. And if anybody wants to see what draft topics are coming up in this work program, they can just contact the NCPs, and we can share the drafts, and we look for comments to try and influence what the content of the drafts are. So the work program comes out. Each cluster has its own work program, And within each work program, there are a number of destinations. So the destinations really provide the policy narrative that the strategic plan sets out. So whatever the Green Deal is looking for, the policy narrative then ends up in part of the work program. There's 3 types of topics that you can apply for. So there's research topic, demo topic, and a CSA. So the research topics are RIAs, research and innovation actions. And these are basically low TRL type topics. So technology readiness level of around 3, 4, 5, maybe up to 6 for research. Those research topics are 100% funded for all partners. Now, the clusters are cooperative topics. So you're going to need consortium of European partners. There's a minimum requirement of 3 from 3 different countries, but typically a research project would have maybe 7 or 8 partners, and a demo project could have between 10 to 20 partners. So the innovation actions are the higher TRL projects. They go from maybe TRL 6, 7, or 8. Now, there is some funding up at the higher TRL from TRLs 8 and 9, but that comes under Pillar 3, and I have a slide on that later on. So you have a work program, you have a destination, and then you have a series of topics. So for Cluster 4, which is the Digital Industry and Space Work Program, the industry topics come in under Destination 1 and 2. So Destination 1 is climate neutral, circular and digitized production, and Destination 2 is the strategic value chains for a resilient industry. The other destinations within Cluster 4 are around ICT, which is digital, so Destination 3, 4, and 6. And then there's a space destination, which is linked to ESA, the European Space Agency. So there's a lot of materials development under that particular program. So Cluster 4 industry part is Destination 1 and 2. So Destination 2 is about materials. So you have raw materials. So the Commission are quite keen to get over the reliance on, say, China for raw materials and rare earth materials. So there's a lot of funding going into looking at new materials, a new digitized, resource efficient, resilient industry. So it's linked to the Critical Raw Materials Acts. So the acts are the EU ways of sort of targeting specific areas, putting in legislation, etc. So there's a Raw Materials Act, and there's a Net Zero Industry Act. There's a CHIPS Act for example, on the ICT side to develop semiconductors. But for materials, it's about, new bio-inspired and biomimetic materials, biomaterials for different applications, whether it be packaging, mobility, energy. So it's across the board. So Cluster 4, even though it's targeting industry, could have a very sort of cross-cutting feature, and could be in terms of security, energy, or the health cluster. So there'd be good links with the health cluster. Destination 1 in Cluster 4 is about production, manufacturing, sustainable production, remanufacturing, 3D printing, etc. And then it talks about the energy intensive industry processes. Now, I mentioned earlier about the actual partnerships. So for Destination 1, the process for Planet Partnership and the Steel Partnership, they all feed into the development of the work programs under these destinations. So that you can see the links, and the very strong links between the partnerships and the destinations in the various work programs. So Cluster 5 is the Climate Energy Mobility Work Program that has 15 billion euros over the 7 years. The 6 destinations, so Destination 5 and 6 are around mobility, so transport, aviation, waterborne transport, etc. And there's very much a focus also on safety and resilience and consumer engagement, etc. Destination 3 is what would be traditional energy areas, so renewable energy, the grid integration, carbon capture and utilization of storage, etc. And Destination 1 is the climate science. So for the Construct Innovate grouping, Destination 4 may be the more interesting part of it. So Destination 4 covers the building stock. So we know that there's very little renovation going on around Europe's building stock. Europe's building stock is quite old. Less than 6%, I think, has been renovated annually. So the whole idea of Destination 4 is to do more renovation and to achieve climate neutrality and transition to zero pollution of the building stock by 2050. There's also an industry part to Destination 4 in industry and buildings, reuse of industrial waste, heat, etc., and electrification and generation. So, I mean, for the 2023 and 2024 work program, there was 2.5 billion in Cluster 5 available. Now, we still have some topics available in 2024 under Cluster 5. Some of the other clusters, the calls are finished for 2024. The deadlines are actually, a lot of them finished in March, but there's still quite a lot of funding available in 2024, and we'll have the 2025 ones. Yeah. So these are examples of topics available in Cluster 5 around the buildings area. You know, there's a deadline on the 18th of April, which is obviously a bit too tight for people to be looking at now, but I do know of Irish coordinators looking at topics here, putting in proposals in this specific area. So the first topic is around prefabricated solutions for energy efficient buildings. There's a topic on smart grid-ready buildings. We have a number of topics all the way out to January 2025. So the deadline is 21st of January 2025. There's 5 topics there. You can see there are a mix of innovation actions or research projects. So as I said, the innovation action is the high TRL. So for example, the first one, D421, is the industrialization of sustainable deep renovation workflows. That's an innovation action. So it's a TRL 6, 7, and 8. They have 16 million euros available for that topic, and they hope to fund around 2 projects. And you can see for the rest of the topics listed there, the number of projects they expect. Some of these areas are quite competitive, but depending on the topic area, I mean, the success rate of Horizon Europe is said to be around 12 to 15%, but that can vary depending on the area of interest. And it's something that maybe you could have a discussion with the national contact points about specific areas to target. So potential topics in Cluster 4 for 2025 to 2027 cover, especially in the manufacturing side, it talks about the tools for design and execution. It talks about human-centric technologies for rapid, safe, circular, resource-efficient assembly, etc. There's tools for construction of products, construction works, and construction and demolition waste. So you see there, a lot of the text is about the digitization. So you have digital twins, data space usage, digital logbooks, buildings, passports, etc. That's a new thing we're seeing quite a lot in the building side and the buildings information management systems. So again, a lot of digitization in the building side and the engineering side of Horizon Europe. Topics that will be coming up in Cluster 5 around the building side from 2025 to 2027 are about the reduction of waste materials, the reduction in the building's energy, more smart grid connected buildings, positive energy balance, etc. So the slides will be available after the webinar, so you can go through it. But you can see very much all about renovation, digitalization, and even there's a lot of topics about using new business models. So the cost of energy is a very important part of a lot of these work programs. Even though if you were doing a research project, the cost of future development is quite key to actually having a successful project. This is an example of a project. It's called Human Tech. It's about human-centered technologies for a safer and greener European construction industry. So it's just an example of a project that was funded. It's funded from Cluster 4 around the construction, manufacturing destination. There's 20 partners. It's led by a German coordinator. And you can see that I'm not sure if you can see it, the writing is a bit small, but the Technological University of the Shannon is involved. They're getting nearly 300K. The project itself is about using wearables for worker safety. Talks about adding technology, robotic technologies for workers. It talks about extended reality glasses, digital twins, and BIM, etc. It's a 10 million project, or 9 million euro project. It's a research project, so it's 100% funded. So there's quite a lot of projects across all the clusters with a similar structure to this. And the scope of the project is quite broad. The last few slides concentrated on the clusters, and the clusters come under Pillar 2. So Pillar 3 is actually for SMEs, really. There's a section in Pillar 3 of Horizon Europe called the European Innovation Council. Now, we could do a whole morning's webinar on this particular area, but I do know people like ÉireComposites would have used this particular part of the program in the past. So there's a section in here called the EIC Accelerator. This is for SMEs. So if an SME has brought a process or a technology up to TRL level 5 or 6, and they want to bring it up to TRL 9 for commercialization, then they can use the EIC Accelerator. The cluster work programs are cooperative, so they require consortiums, but the EIC Accelerator means an SME can go in on their own. And as well as getting funding, grant funding, they can also look for equity funding. So we have 3 NCPs in Enterprise Ireland just covering the Pillar 3 areas. It's a quite popular area for SMEs, and Ireland are doing quite well in terms of getting funding from it. So the EIC Accelerator is a very interesting program, and it's 70% funded with overheads. I just wanted to mention two other areas of interest. So the Commission linked to Horizon Europe also started a number of missions a few years ago. And one of the missions is the Climate Neutral and Smart Cities mission. So what they did was they selected 100 cities across Europe, and in Ireland, Cork and Dublin have been selected. So they're hoping to make those 100 cities climate neutral by 2030. Now that's a big ask. Trying to get Dublin climate neutral by 2030 is going to be a huge ask. But there will be big push in the next few years from Cork and Dublin councils and the various government departments to support the Commission in this particular mission area. The mission area also has its own work program, and up on the right-hand side you can see we're going to have a new set of topics coming out next month for the missions. There'll be 30 topics across this 5 missions. I think there are something like 400 million available, and I just listed some of the topics around the cities mission that will be coming out. So rethinking urban areas, zero pollution cities, mobility management, etc. So we have contacts in all these particular areas. So Dublin City Council and Cork City Council have actual contacts for the mission city projects. So if people want to get in touch with them, they can let me know. Another area of interest is the new European Bauhaus. So I mentioned the Green Deal earlier. So we have a Green Deal, which is trying to make Europe climate neutral by 2050. But to bring that down to the citizen level, they have this new European Bauhaus initiative. It's about connecting the Green Deal to our daily lives and living spaces. It's about connecting it to people. So it talks about sustainability and also about the aesthetics of where we're living. So we will see a lot of funding into the new European Bauhaus through the various work programs in the last few years of Horizon Europe work program. And again, we have a contact in the Department of Housing looking at the new European Bauhaus. And then another area I just wanted to mention is there's a LIFE program. Now the LIFE program was principally the biodiversity program, but there is a sub-program under LIFE. It's called the Clean Energy Transition. It's there for CSA projects, so coordination support actions. So it's about market uptake. It's about energy efficiency, get more people to use more energy efficiency projects. So projects like Super Homes, which Tipperary Energy Agency run, they would have got funding from this LIFE program. There's a call coming out on, I think it's the 26th of April. We'll have a deadline of around September. And one of the topics may be of interest to the engineering fraternity is the build-up skills. And this is about developing up new methods for certification, linking networks of engineering, etc. These are as I said, they're CSAs, they're 95% funding. And the good thing about the build-up skills call in September is that you don't need European consortium to target it. It can be targeted by a single entity from Ireland. So if there's engineers of Ireland are looking at developing up a new method to give qualifications, etc., they could look at this particular topic. And we've been quite successful at it in the past. So Limerick Institute of Technology, now TUS, have used that particular topic. So that was a sort of a whirlwind through the Horizon Europe. I mean, there's quite a lot of information out there. This final slide are a list of the contacts for the various areas for Cluster 4 and Cluster 5. So if you're interested in the industry side, my colleague Sergio Cabalas, who's in Enterprise Ireland, covers that. I cover energy, Bob Flynn covers transport. If you go to the horizoneurope.ie website, you can sign up for newsletters. You can take particular areas. You can be specific on what you want to receive, so you're not receiving everything. And you can also find a full list of contacts. And we have another 3 years left in Horizon Europe, and we'll probably have about 60% of the funding still left. So the funding ramps up as we get towards the end of Horizon Europe. So again, all to play for in terms of funding available. So that's it, Magda.